Understanding lines, meaning linear functions and linear equations, is incredibly important. The concept of slope or rate of change and equations of lines are two of the fundamental ingredients or ideas in calculus. So lines are incredibly important, and lots of things in life can be modeled by linear equations. So here I'm going to run through three equations of lines. I'm going to start with the one that's most helpful. This is known as point slope formula. And if you were to change the way that the slope equation looked by just doing a little bit of, some might call it cross multiplying, even though I hate that word and I'd rather that no one ever used it. But if you took the slope equation and you cross multiplied it, you would have this equation right here. And so you might say, well, okay, how does this work? Well, right here and right here, you plug in a coordinate, x1 and y1. Make sure that x is paired with x, y is paired with y, and then you can plug in your slope right here, and that will give you the equation of your line. Remember, equation, notice how we have our equal sign here. So you would just plug in these three components. Everything else in blue just stays there, and it's part of the general structure of the equation. And it's really nice if you have a point and they give you a slope, or maybe let's say you have 2 points, you could find the slope between them and then use one or the other point, plug it into this equation. You'd have the equation of a line in point slope form. Now this equation is nice if you're given a graph, let's say, and you can clearly see the y-intercept of the line that you're looking at. Or if they just give you the y-intercept, you can write this equation of the line that you're dealing with. However, only if you have the y-intercept can you use slope-intercept form. And so that's your intercept, there's your slope, so that hence the name slope-intercept. Just like in point slope, here's your slope, there's your point, hence its name. But so slope-intercept, even if someone gives you the y-intercept, you could still use point slope form. So slope-intercept form, it's good to recognize. It's, sometimes it's quite useful, but it's only useful if you have the y-intercept. So it's kind of specialized. In standard form, you could see some sort of equation like this. ax plus by equals c. If you want, you can find the x and the y-intercepts of this interesting equation here. Let's actually do like an example. Let's say I had 4x minus 8y equals negative 32, let's say. That's in standard form. If I wanted to find the x-intercept, I would make y be 0. If y was 0, I would have this. And I could solve this equation. If y is 0, I'll just have 4x on the left-hand side. And divide by 4, boom. X is negative 8. So when y is 0, x is negative 8. That's known as the x-intercept. You could play the same game, and you could make x be 0 and get your y-intercept. Y would actually be 4 when x is 0. So then you could actually plot your x-intercept here at negative 8 and your y-intercept at 4. Then connect those 2 points, because 2 points determine a line. And that's how we could graph this line in, let's say, standard form. So you have to be familiar with all three forms, and they're quite important. So I already went through a very quick example of graphing something in standard form. Let's graph something in point slope form, just because it's kind of funky. So we had y minus 8 equals negative 3 times x plus 1. So we must recognize that this is in point slope form. I can just grab the slope right away. The slope is negative 3. And now the point. Now remember, on the previous slide, point slope formula usually has a minus sign in between the x and the y, just like slope has it's the change in x and change in y, so you have that subtraction symbol. The x coordinate here is going to be -1, because if you think about it, there's like a double negative there. It's like x minus -1. That means the x coordinate is -1. Minus a minus turns to a plus, so that's why we have it represented as x plus 1. The y coordinate, we can just pick that right off, is 8. So again, you have to be careful. It's y minus y1. So y1 is 8 equals the slope x minus x1. So just be careful for that double negative there. All right, so now we have a point on the line. Left 1, up 8. There's our point, our coordinate. And then our slope, a negative slope would be like going down 3, right 1. You can plot a point there. Down 3, right 1. Down 3, right 1. And then that's how our line would look. It goes through the point, -1, 8, and it has a slope of -3. Down 3, right 1. Okay? And in y equals mx plus b form, things are quite nice. Let's say we had an example like y equals 2x plus -4, let's say. Our y-intercept would be down here at -4, and our slope would be up 2 over 1. And I'm just kind of counting it out. And there's our line with positive slope 2, up 2 over 1, meaning up 2 right 1, and a y-intercept of -4. So you got to be able to graph lines, recognize their graphs, and kind of work forwards and work backwards. Also, when in doubt, make a table, plug in an x value, and see what the y value is. That's a good way to get a handle on a graph that you're not sure which equation it represents. You should always have a true statement. If you're looking at a graph, and let's say you have like 4 multiple choice answers for the equation representing that graph. You should be able to pick some points on your graph, plug them into each of the equations, let's say answer choices A, B, and C, and D, and you should always get a true statement, because any point on a line is a solution to the given equation. So that's some more food for thought, let's say. So just some quick examples of things that are not linear, because it's always good to have examples and non-examples. This function y is nonlinear because it's the product of 2 linear factors. So this is linear and this is linear, but when you multiply them together, if you were to use the distributive property from our earlier video, you would see that this actually is degree 2. If you were to graph this out, maybe make a table, plug in some x's, see what the y values are, you would have a parabola. This does not have a constant slope. This is not a line. Or you could just be given a parabola like so, let's say, x squared minus 3. Or, here's another parabola. Similarly, 2 to the x is nonlinear. If you were to graph that, you would see that it has a non-constant slope. Similarly, if you had, let's say, 3 over x minus 1, that is not linear as well. So it's important to have like a kind of a mental picture for each of these situations. Right, so finding slope is incredibly important. So let's say you're given 2 coordinates. Let's call them x1, y1, and x2, y2. Alright, so you're given these 2 coordinates. If you want to find the slope between them, the slope is the change in y over the change in x. And to make the equation for slope, meaning utilizing an equal sign, we'll say m equals. And I believe m is French from monter, which is the verb to like go up. So I think that's where m came from. Okay, so again, we have 2 points, x1, y1, and x2, y2. We have these 2 coordinates or locations on the grid, and then we can find the slope in between those 2 points by subtracting y2 minus y1 over x2 minus x1. So let's say that we had the points 2, -3, and 5, -7. The slope would be the change in y, so start with y2, minus y1 over x2 minus x1. Minus minus turns to plus, we have -4/3. Now that slope is going to look like roughly like that, little down 4, right 3. Okay, remember negative slope from left to right decreases. Positive slope from left to right increases or goes up. To find a y-intercept, you'll just plug in x equals 0 into your equation. You might wonder why. Well, if you think about the grid or the xy axes, anywhere that you're going to hit the y-axis, your x-coordinate is 0. So for instance, what's the coordinate at that point? Well, that's a y-intercept. It certainly hits the y-axis. Let's say that's 0, 6. Notice the x is 0. Similarly, right here, let's say that's, a y value of -5. The x-coordinate is 0 because we are, again, on the y-axis. So just for fun, by the way, if I wanted to know the equation of this vertical line, that's the line x equals 0. Because if you think about it, every point on the y-axis has an x-coordinate of 0. Like this is 0, 6, 0, -5, 0, 0, 0, -1. So that's another interesting idea as well. So you just have to have confidence with linear functions, and if you're given a bunch of graphs, you can plug in information and kind of get to the bottom of things. So proportions are super duper important. If there are, let's say, 4 snorfs for every 7 blots, then how many blots are there if you have 101 snorfs? So again, we want to find how many blots. So I'll put my x down here. So notice this proportion. This proportion here, I have a ratio, an equal sign, and another ratio. Ratio just meaning fraction. When I set these two ratios equal, I have a proportion. I'm always going to maintain a snorf to blot ratio, meaning snorfs are in the numerator, blots are in the denominator. Snorfs are in the numerator, blots are in the denominator. You will have proportion questions on your test, and it's always important to maintain this correspondence. Snorfs in the numerator, blots in the denominator. Snorfs in the numerator, blots in the denominator. I feel like we had a problem as well where we had like one astronomical unit was 93 million miles. So that's AUs to miles. How many AUs if you travel, 140 million miles? It's the same idea, comparing astronomical units to miles. So now, in this problem right here, we can just cross-multiply, which I hope you never tell your students to cross-multiply. But in the essence of saving time, that's what we're going to do. We'll divide by 4x. Remember, x is in blots. It will be 707 blots, which 4 goes into 7 once, there's 3 remaining. 4 goes into 37, there's 28, so 2 are left over. 4 goes into 27, 6 times, and 3/4 remain. So if there's 4 snorfs, for every 7 blots, 101 snorfs would yield 176 3/4 blots. So proportions are very, very important, and just make sure you set yourself up for success. So lots of things in life can be modeled by linear equations. Let's kind of run through these, and if I were you, I'd pause this video and I would use a little y equals mx plus b for each of these situations because we have a slope and a y-intercept. All right, UPS charges $1 for all shipments in addition to 40 cents per ounce. So y, which would be how much you have to pay UPS, it would be $1 no matter what, and then it's 40 cents per ounce, where x is the number of ounces. So notice, if you're going to ship something that weighs 0 ounces, you owe $1 to UPS. If something weighs, let's say, 2 ounces, you owe an additional 80 cents plus that dollar. So no matter what, that's like your y-intercept. You owe me one bill. You owe UPS $1. However, 40 cents per, that really means you're going to be multiplied or attached to X, which is the number of ounces. So this 40 cents per ounce, that's code for your slope region. And again, I could have written this like 0.40x plus 1. We're saying the exact same thing. So now let's try the second one. Alright, so from the top of a 1,700-foot mountain, a hiker descends down down the slope of the mountain at a rate of 150 feet per hour. Write an equation for his current elevation. Well, at time 0, and I'll write the y-intercept secondly this time because I feel like it. At time 0, we'll think of y as the output or the elevation. At time 0, the elevation is 1,700. However, he's decreasing at a rate of 150 feet per hour. So x is the number of hours, so 150 feet per hour plus that 1,700. And then you can kind of think about this. Does it make sense? Well, if he's been climbing down for 10 hours, he's gone down negative 1,500 feet, which means he'd have 200 feet left. That kind of works out in the equation. So things you can have, positive slopes or negative slopes. Again, notice in both of these situations, the slope was attached to x via multiplication. Make 250 a week, that's your y-intercept. You start out with 250 plus $9 per sale, where x is the number of sales. Y would be the total amount of money you are paid. Okay, very good. Feel free to check out Deborah Borkovitz's questions on this. She does a wonderful job. And have a glorious linear day.